Hi, hello friends. Welcome to today's session. Welcome to Unacademy and welcome to Srinivasarao Sir classes. So in this session, we are going to cover the problematic session which is on flow control protocols, that is stop and wait and sliding window protocols. My dear friends, before starting the session, let us all say our anthem, crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. As we all know that Unacademy has created a wonderful online platform which brought all the dedicated faculty members onto a single route, which are providing services to dedicated students who wants to make your life into successful manner. My dear friends, my name is Srinivasarao Sir, having more than 15 years of experience in the GATE with the various subjects. I also had industry experience as a system analyst and data admin. Throughout my journey of GATE, I taught in many premium academies with a high success rate. So very with high success rate because many of my students got single digits and double digits ranks. My dear friends, they all settled in their life in a successful. They have settled in a topmost positions in topmost companies. You also can be. Question mark yourself whether how you want to keep your life in a fruitful manner. So to do all this, you need to take admission into an academy to clear the prestigious competitive examination conducting by HRD of India, nothing but GATE. So if you qualify and clear your GATE examination with a good rank, then you're going to complete your dreams by studying or completing your post-graduation from IITs, NITs and IIIT. My dear friends, all you need to do is just to give your valuable admission so that Unacademy is going to take care of you. There are two kinds of subscription, 12 months and 24 month subscription. So Unacademy is also launched 18-month subscription so that all first, second and third year students and fourth year students can begin your GATE career. So once you get the admission into Unacademy, you're going to get live lectures, live quizzes, mock sessions, and anything whatnot which is available on an academy portal. They are all going to be helpful in the examination to crack your GATE examination. My dear friends, Let's Crack GATE CSE is our YouTube channel. Subscribe our YouTube channel. Hit the bell icon for latest notifications and updates. I use my referral code to get the admission into an academy. Once you get the admission into an academy using my referral code, I can be a guide to you so that I can able to guide each and every point how to clear your GATE examination. Because a GATE examination requires some kind of guidance apart from your preparation and content. Because what to answer, what not to answer, that's very important. Those tips I'm going to provide as I'm going to be your guide once you took your admission using my referral code. My dear friends, so let us start our problematic session using a stop and wait protocol and a sliding window protocols, because these two are used to produce control over the flow of transmission from sender to the receiver. One is acknowledgement based, the other one limit based or rate based. So before solving the problems, so these are the equations we need in order to solve all your problems in stop and wait. So you can take a screenshot before solving these problems. One, how you can able to calculate propagation time. The other one, how you can able to calculate transmission time. The other one is a link efficiency. We always use this formula and this formula 100%. And throughput is nothing but link efficiency into sender's bandwidth or message size divided by total time. Now let us see the first question. So he is asking how many number of bits fit in the channel. What is the meaning of that? He is asking a link capacity. So how to find the link capacity, which is nothing but bandwidth into 2 into TP if I am using a full duplex channel. If it is half duplex channels, bandwidth into only TP. This is your half duplex channels. This link capacity is also called as volume of the pipe. There are two volume of the pipes I already discussed in the theory lectures. One is a thin channel, the other one thick channels. So thick channels, the volume of the pipe is going to be very high. Thin channels, the volume of the pipe is very less. Now let us discuss what is your bandwidth and what is your 2 into TP. Already TP is a mention, so it is nothing but 10 milliseconds. So milliseconds I can able to write in this form. So 2 into 10 ms, it is nothing but 10 into 10 power minus 3. And your bandwidth is 100 into 10 power 3 bits per second, because your kbps I can write in the form of 10 power 3. Now you decide. This 10 power 3 cancel हो जाएगा, second cancel हो जाएगा. What is the rest of the thing? 2 into 10 into 100. So 20 double 0 and bits are missed. So you can say your answer is what? 2000 bits. If you look at your channel, if you look at your medium at an instance of time, you able to see that there are 2000 bits are there. That is the meaning of volume of the pie. If you take half duplex, my dear friends, it is half of to that. So 1000 bits half you take, which is nothing but 2. And once you see that, you are going to see only 1000 bits only. That means what is the meaning of half duplex communication? Only one party is sending, other party is receiving. But here, this party also can send and this party also can send, and 1000 bits from sender side and 1000 bits from receiver side, both will be at one particular position, which is nothing but volume of your pipe or number of bits which are there in your cable. Let us see the second question. He is asking question on stop and wait protocol. So what is his intention? His intention is that what is the total time it takes to send a 10 power 6 bits? What is the meaning of total time? Total time is nothing but, let me give you figure out. I have transmitted your data using a TT and I supposed to get acknowledgement to transmit a next frame TT. So this is completely called your total time only. So how much it is? Let us see. So a frame can carry 1000 bits, but you want to transmit 10 power 6 bits. Observe carefully. Therefore, my dear friends, your number of frames is equal to 10 power 6 bits are total your message size divided by your frame can carry maximum of 1000 bits, which is nothing but 10 power 3. So how many frames you need? I need 1000 frames. So 10 power 3 frames I need. Now let us see. TP you need to calculate because this is a TT and this is your TP and this is your TP. I am using a stop and wait protocol. That means only one frame at a time you can able to transmit. You cannot transmit all the 10 power 3 frames at a time. This is a very important thing. First one frame, then next frame. Likewise, I will transmit up to 1000 frames because my data frames are altogether 1000 because my message size is the 10 power 6 bits. So first let us calculate your TT and TP to say your final answer. Your TT is nothing but length of message upon bandwidth and your TP is nothing but distance by speed. So both you need to calculate. First let me calculate TT. So frame capacity is 1000 bits. So what is our bandwidth? What is the total time it takes to send 10 power 6 bits when it is uses data transmission in the frame and which is using a stop and wait protocol? So let us see your TP now. 5000 kilometers divided by 2 into 10 power 8 meters per second. 5000 kilometers divided by 2 into 10 power 8 meters per second. So what is your answer? It is a 5 into 10 power 6 meters divided by 2 into 10 power 8 meters per second. Therefore, observe my dear friends. So it is a 2.5 into 10 power 6 meters cancel into 10 power minus 8 s. What is your answer? 2.5 into 10 power minus 2 s. I can able to keep it a nearest one, that is a 25 into 10 power minus 3 s, which is nothing but 25 ms. Well, my dear friends, now let us calculate your L by B also. Your L is, please observe carefully, your frame size is, a frame can carry 1000 bits and your message altogether 10 power 6 bits. Therefore, total I need to send 10 power 3 frames. Let me calculate for one frame first. So 1000 bits divided by, what is our bandwidth? So no bandwidth is mentioned. So I can able to take here that what is the total time it takes to send a 10 power 6 bits when it is uses a data transmission in the form of frame and using stop and wait protocol. So my dear friends, how to calculate your bandwidth? So you want to calculate your bandwidth, there is a requirement of TT time. TT also I don't know, therefore it is impossible to calculate TT here. Then what I am going to do? So how much time you are going to transmit your, what I mean to say, data from sender to the receiver, which is nothing but one frame. If you observe, I am taking a 25 ms, then I am going to take how many frames here? 10 power 3 frames I am taking, therefore 10 power 3 into 25 ms. So this is your total TP time. Now let us look at next question. Suppose stop and wait protocol is used on a link with a bandwidth of 64 kilobits per second. So bandwidth is equal to 64 kilobit per second and 20 milliseconds propagation delay. So one way propagation time is 20 milliseconds. Assume that all other delays, secondary delays are negligible. You can make it nullify 0. What is the minimum frame size in bytes to achieve link utilization to 50%? We already know 50% efficiency rule. L is equal to bandwidth into 2 into TP. If your L value is equal to this much, then you are going to get a 50% of efficiency, no doubt. He is asking L value only. So L is equal to bandwidth is 64 kilobit per second into 2 into TP is nothing but 20 ms. So this is 64 into 10 power 3 kb means, and to 20 into 10 power minus 3 s. 1 ms means 10 power minus 3. Therefore, this and this is a cancel. This is a cancel. So your answer is 64 into 2 into 20. So this is bits only you got, but he asked in the form of bytes divided by 8. It is 8 8 is 64. So 8 2s are 16, 16 20. 16 2s are 320. It is nothing but 16 into 2 into 20 bytes. So this is your answer. My dear friends, so we got into bytes format. What is the link efficiency to get a what? 50% of efficiency. Now let us see another question. Bandwidth is equal to 100 Mbps and your distance is equal to 24 km and the speed is equal to 3 into 10 power 8 meters per second. Your L value is equal to 16 kilobit and he is using stop and wait protocol. What he wants? What is the link utilization? He is asking L of U. What is L of U? TT by TT plus 2 into TP. You can also call it as 1 by 1 plus 2A. Just to find A value, remaining we will take care of it. TP by TT, your A value. So what is the TP? You need to calculate. TT also you need to calculate. So let me calculate here. TT is nothing but L by B. L upon bandwidth. So where L value is 16 KB, bandwidth 100 Mbps. So Mbps, both are in bits only, no conversion required. 16 into 10 power 3 bits divided by 100 into 10 power 6 bits per second. So what is your answer? This and this is a cancel. So 160 into 10 power 1 into 10 power minus 6, which is nothing but 160 microseconds. This is your TT. Let us calculate TP here. Your TP is distance by speed. Distance is given. So what is the distance is given? 24 km into 3 into 10 power 8. 24 km divided by 3 into 10 power 8 meters per second. So numerator is in kilometers, so convert into that 10 power 3 meters divided by 3 into 10 power 8 meters per second. So 3 8 ja. So 8 into 10 power 3 into 10 power minus 8s. Your value is 8 into 10 power minus 5s. This is in a microsecond, so this also I am going to put it in a microsecond. 82 microseconds. So you got TT value and TP value. So 1 by 1 plus 2 into. So what is the TT? 160 microseconds. So 80 microseconds divided by 160 microseconds, which is finally 1 by 1 plus. This is 0.5. It is nothing but 1 by 2, which is 50% is your efficiency. So we got your answer that 50% efficiency. Well, my dear friends, you can also make it equal to L is equal to BR. You will get 50% efficiency without any doubt. 50% efficiency, you are going to have L is equal to 2 into TP into your bandwidth. This is your 50% of efficiency. Let us solve one more question. So stop and wait protocol is using your frame size. L is equal to 1000 bytes given and the transmission rate bandwidth is equal to 80 kilobit per second and the size of acknowledgement, this is very important, acknowledgement size is equal to 100 bytes and receiver bandwidth, this is sender bandwidth, this is receiver bandwidth, extra component we are getting here. So receiver bandwidth 8 kbps. Propagation delay is 100 milliseconds. What is asking? Throughput is asking. What is the throughput? So actual number of data transmission is nothing but your throughput. How are you going to calculate your throughput? Which is nothing but link efficiency into sender's bandwidth. This is your throughput answer. Otherwise, message size divided by total time. So L of u we want to find here. So I'm going to find L of u. Link efficiency is nothing but 1 by 1 plus 2a, but don't use this formula here. This is only for primary delays only. But here one more delay is added. That is nothing but, please observe, I need to use this equation now because denominator is increasing. That is Tt for data divided by Tt for data plus 2 into Tp. This is our regular expression. I can able to put it in this form. But I am adding a one more component according to the examiner. That is a transmission time for acknowledgement. This is also given. So you need to consider all of them. So let me calculate first Tt for data. So what is your Tt for data? Length depends upon your bandwidth, sender's bandwidth. So what is your frame size? 1000 bytes with 80 kbps. 1000 bytes with 80 kbps. Multiply with 8. Because this is in bytes, this is in bits. So 10. So your answer is 100 into 10 power minus 3s, which is nothing but 100 milliseconds. You got Tt for data. Now you need to find Tt for acknowledgement. What is the Tt for acknowledgement? Your length of acknowledgement divided by receiver's bandwidth. This is sender's bandwidth. So acknowledgement size is 100 bytes and receiver bandwidth is 8 kbps. So this has to be multiplied with 8 bits because the numerator is in bytes and denominator is in bits. So 8 8s cancel ho jayega. Your answer is 100 into 10 power minus 3s. So this is also 100 ms. Got it? You have got your answer. So your L of u is nothing but, your L of u is a Tt for data. What is a Tt for data? 100 ms divided by 100 ms plus 2 into Tp is how much? Tp is also 100 ms only. 100 ms plus Tt for acknowledgement. This one. Tt for acknowledgement is equal to 100 ms. So what is your final value? 1 by 4, which is nothing but 25% is your efficiency. Right, my dear friends? So you got final value. I am doing a throughput now. So your throughput is 1 by 4 link efficiency into sender bandwidth is 80 kilobit per second. So bus, you got 20 kilobit per second. This is your answer. Your answer is 20 kilobit per second. But he is asking answer in the form of what? Bytes. How are you going to get the bytes? Your 20 kbps divided by 8. So you are going to get answer in the form of bytes per second. So this is a 2.5. kb is nothing but 10 power 3. I can still squeeze it. 2500 bytes per second. So your answer is 2500 bytes per second. Well, my dear friends, let us start one more question. Now you observe. Straight away question. So what is the frame size to get a minimum 50% of efficiency? Very simple. L is equal to bandwidth into 2 into Tp. Bus. This will give you 50% of efficiency. You can find bandwidth, you can find Tp, you can find Tt, whatnot. Everything you can find using this equation, my dear friends. So what is your bandwidth? 4 kilobit per second into 2 into Tp is 20 ms. So Kb means 10 power 3 bits per second. 2 into 20 into ms is a 10 power minus 3s. So this and this is a cancel. Seconds also cancel. And remaining value is a bits 4 into 2 into 20 b, which is nothing but 160b. This is your answer. So let's crack one more question based on stop and wait protocol. He said that bandwidth is equal to 20 kbps, propagation delay TP is equal to 50 ms, transmission time is equal to 2 times of your propagation delay, TT is double of your TP, which is nothing but 100 ms. He is asking what is the packet size for stop and wait protocol. Please understand, he is asking what is the L value. Let us check like this. First of all, let me tell you what is your TT. Your TT is L by B. TT already mentioned how much? Double of your TP, which is nothing but 100 ms. I don't know L value, but I know bandwidth. What is your bandwidth? 20 kbps is your bandwidth. So this one we are going to find L value, I don't know. So how are you going to find L value? So which is 100 into 10 power minus 3s into 20 into 10 power 3 bits per second. KB means 10 power 3, MS means 10 power minus 3. So finally, my dear friends, SS is cancelled and remaining metric measurement is a bits. So 100 into 20, which is 2000 bits. He is asking in the form of bytes divided by 8. So which is nothing but 25 . So 100 into 20, 2000 bits divided by 8. So what is our answer? So it is your answer is 250 bytes. Now come to next question. So you need to set your efficiency to 25%. Earlier we computed for 50%. Now he is asking for 25% efficiency. What he is asking? Find propagation delay. This is what he is asking. And he said that all secondary delays are negligible. All secondary delays are negligible. So we are going to consider only what? Primary delays only. Consider primary delays. That is a TT and 2 into TP. TT plus 2 into TP. Right, my dear friends? So let us find out TP for 25% of efficiency. So what are the parameters are given? Let us take. The parameters are given as bandwidth is 10 power 6 bits per second. Packet size is L is equal to 1000 bytes. And what else? Nothing is mentioned. You need to calculate the propagation delay, which is to be equal to 25% of link efficiency. So let us calculate, my dear friends. What is your link efficiency? Link efficiency is a TT by TT plus 2 into TP. Otherwise, you know, 1 by 1 plus 2a. Any of the equation you can use. Now I am using the first equation. TT you need to calculate. So TT is L upon bandwidth. So L is already given 10,000 bytes and bandwidth is 10 power 6 bits per second. Okay, my dear friends, 10 power 6 bits per second. Now let us calculate TT. So this denominator is in bytes and the numerator is in bytes, convert into bits formation, which is 8 into 10 power 3 into 10 power minus 6s, which is nothing but 8 into 10 power minus 3s. This is nothing but 8 ms. So you have converted into 8 ms. So let us keep here. This TT by TT plus 2 into TP is actually 100% equation. He is saying that make it to 25%, which is nothing but 1 by 4 only. So what is your answer? 3TT is equal to 2TP. That means your transmission time is nothing but 3 times of your transmission time to make it equal to 2 into TP. Now let us see. So he is asking TP value only. So your TP is nothing but 3TT divided by 2, which is nothing but 1.5 of your TT. And now you got your answer. What is that? Your TP, one-way propagation time from sender to the receiver, is nothing but 1.5 times of your TT. This is what is the inner meaning of it. So what is the TT? 8 ms. So 1.5 into your 8 ms, which is nothing but 12 ms. This is your answer. So your TP according to 25% of your efficiency is 12 milliseconds. Well, my dear friends, look at this case. So sender is sending 500 packets. This is one of your previous gate question. Sender is initially transmitting to the receiver 500 packets. In this 500 packets, all are not success. There are some lost. How much is the lost? Error rate is a 0.2. These are going to be lost. When these are going to be lost, 0.2 on your 500. 0.2 on your 500 is 100. These 100 frames again sender is going to retransmit to the receiver. And these 100 frames will not be transmitted successfully. Again there is a 0.2 error rate, which is nothing but 20. Again sender is going to retransmit these 20 frames to the receiver. But this 20 also will not be transmitted carefully because you see that 0.2 error rate. So you got 4. Again sender is going to retransmit these 4 to the receiver. Again these 4. Again 0.2. So 4 on your 0.2 is nothing but 1. This is going to be transmitted from sender to the receiver. What are the total transmissions from sender to the receiver? That is the question. Initially I send 500. Then I send second 100. And next 20. Then next 4. Next 1. How much it is altogether? So 625 transmissions I did. 625. What is the average number of transmission attempts required? Is nothing but 625 frames I have sent. So how did you get this? This you have got using such a long equation. Instead of that, there is a shortcut. What is that? For every frame, the success rate is 1 minus p. For every one frame, 0.2 is a lost case. So for every one frame, your success rate is 0.8. So how many frames you have transmitted? 500. So 500 divided by your 0.8. So 500 divided by your 0.8, 625. You got the answer. This is a shortcut to the previous question. Or you want to use the process, you can use the process like this. Otherwise, you can go the shortcut like this. Simply you can able to do n by 1 minus p, you will get the total number of transmissions. Let us say sliding window protocol. These are the equations I am going to use. How to calculate window of bits, how to calculate window size, how to calculate optimal window size, this and this is same, and how to calculate the n bit value. Are you getting 100% efficiency or not? And what is the sender can able to send? What is the equation for sending of your data? So these are the things we are going to discuss. Take a screenshot of this because we are trying to use these equations while solving the problems. First one is optimal window size and n bit value is asking. What is optimal window size? Your window size is nothing but 1 plus 2a. This is a direct equation. Observe carefully. 1 plus 2a, otherwise window of bits divided by packet size. Anything is same. So 1 plus 2a, a is nothing but TP by TT according to our example only, like a stop and wait. Now already TP is present to you, which is a 2.5 seconds. You need to calculate TT. Your TT is L upon bandwidth. What is L value? 1 kilobyte, which is nothing but 10 power 3 bytes divided by your bandwidth is 1 Mbps, 10 power 6 bits per second. This is in bits, this is in bytes. So conversion is required. So your answer is 8 into 10 power 3 into 10 power minus 6 s, which is nothing but 8 ms I can write. So you got your TT also and you got your TP here. So let us post it here. 1 plus 2 into TP by TT. TP is in seconds and TT is in milliseconds. So let us convert into seconds or milliseconds, whichever format you want, you can able to do it. So it is nothing but 2.5 seconds divided by your 8 milliseconds. So my dear friends, this is your window size. You can also find n bit value. How to find n bit value? Which is nothing but log base 2 of your window size. Bus. You got two values. Optimal window size is this much and your n bit value is nothing but log base 2 of your window size. So you do the calculation part. Next one, which is another very important question. 2-bit sequence number is using by sliding window protocol. So can you say what are your available sequence numbers? Your n value is equal to 2-bit, which gives you available sequence numbers, which are 2 power 2, which is nothing but 4, which is nothing but 0, 1, 2, 3. But sender window size how much? It is a 2 power n minus 1 because window is reset from 2 power n to 2 power n minus 1 to detect the ambiguity. So finally, how much is the sender window size? 3 frames at a time. Now tell me, so sender can send initially in the first attempt, in the first phase, he can transmit 0, 1, 2 only. Next, second phase. So next to second phase, he is going to transmit next 3 frames. So your second phase begins next 3 frames, because every time you can transmit only 3 frames only. So next 3 frames are 3 is left still, and these sequence numbers will be reused continuously. So 3, this completed. Next 0 will come, 1 will come. Next, after that third phase I am starting, which is also 3 frames only he can able to send. So 0 completed, 1 completed. Next numbers are 2, 3, then followed by 0. And next fourth phase I am starting. There also you are going to send 3 frames only. Already 230 you have used. So what are the next numbers? 1, 2, 3. So how many frames are completed so far? Let us see. Fifth phase also. So your fifth phase is going to start. After 3, I have started 0, 1 and 2. Now tell me. He is asking what is the frame sequence numbers of 14th transmission? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is your answer. Your 14th frame sequence number is 1. Your 14th frame sequence number is what? Frame number 1. So this is a very important question, my dear friends. Now let us start. Another question. M is a maximum sequence number in sliding window. Calculate the number of frames can be transmitted in sliding window in a 1 RTT. M is a maximum sequence number. When I am saying M is a maximum sequence number, let us say your numbers. Let sequence numbers are, assume 0, 1, 2, 3, 4, 5, 6, 7. What is the maximum sequence number in this list? The maximum sequence number in this list is 7. Maximum sequence number is 7. That means sender can send how many frames? 7 frames only. Because your sequence numbers are 8, 0 to 7, sender can send only n-1 frames only. The n-1, which is the number, whatever the number maximum sequence number you are choosing, that the sender can able to use, which is nothing but 7. Therefore, if m is the maximum sequence number in sliding window, how many number of frames I can able to transmit? M frames only. This is your answer. Your answer is m frames, which is nothing but here according to this example 7. Whatever the maximum sequence number is there in your particular pool of sequence numbers, those many frames the sender can able to send, which is equal to 2 power n-1 only. Observe. This is equal to 2 power n-1, where n is nothing but number of bits required to represent your sequence number. Now let us see another question. In sliding window, the transmitter window size is n. Transmitter means sender. Sender window size is equal to n, and receiver window size is also n. Let us say m. Receiver window size is mn. So one guy is a m and the other guy is a n. Now he is asking, what are the total sequence numbers in sliding window? Total sequence numbers in sliding window protocol, which is nothing but very simple. SW plus RW, which is m plus n, is your answer. You want me to give proof? I will give you. Sender window size is equal to 3. Receiver window size is equal to 4. So your available sequence numbers are 3 plus 1, which is nothing but 4, which are 0, 1, 2, 3. Sequence number always starts from 0, ends with n minus 1. So you got your answer. So sender can send only 3 frames, receiver can send only 1 frame. Now let us see. Sender window size is n. So sender window size is n. And n frames are transmitted. These n are transmitted. For example, let us say if n is equal to 3, then 3 frames are transmitted, which are numbering from frame 0, frame 1 and frame 2. And it is supporting cumulative acknowledgement. So if 0 success, 1 success, 2 success, what the sender will give you, receiver will give you acknowledgement is in the form of cumulative, because it is supporting cumulative system. Cumulative means plus 1 to your last successful frame. So your last successful frame sequence number is a 2 and I am adding a plus 1 to that. So I am giving a positive acknowledgement for 3. When you say 3, the 3 covers that 2 success and the previous one is also success and the previous one is also success. So n minus 1 success, n minus 2 success and n minus 3 is also success. That is the meaning of what? Cumulative acknowledgement. So here he has transmitted acknowledgement P means he has given acknowledgement P, positive acknowledgement P, which means acknowledgement P means what? Positive 3. I am saying, for example, positive 3 means the receiver received 3 frames. Receiver received 3 frames. How he has received 3? 0 success, 1 success, 2 success. That's the meaning. So whenever you are giving a one number as a positive acknowledgement, which covers your previous particular acknowledgements or received frames. Therefore, how many frames are received by receiver? Which is nothing but P only. Here P is nothing but 3. If whenever he is sending a positive 3, which means you have receiver might have received 0, 1, 2 successfully. Now let us see. If n is the total sequence numbers are used, your total available sequence numbers are 0, 1, 2, 3, 4, 5, 6, 7 and I am assigning this to n. What is your sender window? What is your receiver window? Receiver window is always 1 and the sender cannot send all these frames. He can send only up to n minus 1 frames only. So when I am giving 8, the sender can send 7. When I am giving 4, sender can send n minus 1. So your answer is n minus 1 here. So now this is one very important question. What is effective window size of the sender in sliding window protocol? Effective window size means according to the capacity of the sender and according to the capacity of your n-bit value. So we are using an equation. What is that? Minimum of 2 power n or 1 plus 2a we will transmit. You know why. Already proof is given. Please watch my previous theory lecture of sliding window protocol. You will understand why I am following minimum of 2 power n comma 1 plus 2a. So I am saying minimum of 2 power n. N is a 6-bit value. And 1 plus 2 into a is nothing but tp by tt. So you need to calculate TP and TT. TP is already given, TT you need to calculate. So what is the TT? L upon bandwidth. So L value 100 bytes divided by bandwidth is 10 power 3 bits per second, KB means, into 8. So what is your answer? 8 into 10 square into 10 power minus 3s. So bits cancel ho jayega, which is nothing but 0.8. So what is your TP is in ms now, so I'm also going to take in the form of ms, so which is nothing but 800 ms. So what is your answer? This is equal to minimum of 2 power 6 means 64, 1 plus 2 into A is 100 ms divided by TT is 800 ms, which is 100 by 80, which is lesser than this particular value. So we are going to take minimum only. So 1 by 800, that means 100 by 800, which is 0.15 into 2 plus 1. So it is nothing but minimum of we got 64 comma 1.25 frames. So your answer is according to that. You cannot send 64, you need to send only how much? 1.25. What is the meaning of 1.25? Sender can send 1.25 frames at a time. That's the meaning of sender window size. According to this, we are following effective window size. Because your n value is given this much and TP value is given this much, after calculation minimum we are going to consider. This is another wonderful question. So your packet size is equal to 32 byte. So L is equal to 32 byte and sliding window protocol, and round trip time RTT is directly given, which is 2 into TP. RTT means 80 ms given, and bandwidth is also mentioned 128 kilobyte per second. So what is optimal window size? Window size is nothing but, I gave you two equations. Either you do with 1 plus 2a or you do with the window of bits by L value. L is nothing but frame size. So I can do any of the style. So you want me to do like this, I will do. Already you have seen this style. 1 plus 2a is nothing but 1 by 1 plus TP by TT. You can use this. Now I am doing this value. WB by L by window of bits divided by frame size of your bits. Window of bits, how to calculate? Window of bits is nothing but your channel capacity or volume of the pipe or number of bits fit in the channel or bandwidth delay product. Window of bits are nothing but bandwidth 128 kbps into 2 of your TP. So 2 of your TP is already given 80 ms divided by your message size 32 bytes. So this is the equation. Let me sort out. 128 kbps into 80 ms into 80 ms divided by 32 kilobytes. This is your window size. Now see, 128 into kb means 10 power 3 bits per second into 80 into 10 power minus 3s ms means divided by 32 into 10 power 3 kb means, and numerator is in bits and denominator is in bytes, so we need to convert into bits. Now let us see your answer. So 32 into 8, so 10 power 3 cancel, 32 byte now, so you need not write this, only 32 bytes into 8. So this value is a 256, 32 into 8 is nothing but 256. So 2 and 240, 10 power 3, SS is a cancel. Finally 40B is left. And B also cancel because here you already did it, B value. So your value is how much? 40. So your window size is equal to 40. What is the meaning of 40? 40 frames at a time. 40 frames at a time sender can send. You can also do using a 1 plus 2a equation. You will also get same, no doubt. So let me do the next question. He is asking throughput of the channel and 1 bit sliding window I am using. Observe carefully. What is a 1 bit sliding window? 1 bit sliding window is nothing but stop and wait only. Because your sliding window protocols are two varieties. One variety is a 1 bit sliding window protocol and the other variety is a n-bit sliding window protocol. If you are using a 1 bit sliding window protocol, which is nothing but stop and wait only. Now he is asking throughput. What is the throughput equation in a stop and wait? In a stop and wait, what is your throughput? Link efficiency into bandwidth. You need to calculate link efficiency now. So link efficiency in stop and wait 1 by 1 plus 2a. So what is a? TP by TT. This is your a. So what are parameters are given? TP is given 40 ms. So you need to calculate TT. So your TT is L upon bandwidth. So L value, same repetition formulas only. That's why once you do 10-15 problems, you are having a good grip on revising your formulas. Your frame size is a 4 KB and bandwidth is 4 Mbps. 4 KB divided by 4 Mbps. KB is nothing but 10 power 3. MB is nothing but 10 power 6. Bits cancel. So which is nothing but 10 power 3 into 10 power minus 6s, which is a 10 power minus 3s, which is nothing but 1 ms. So you got 1 ms. So 40 ms divided by 1 ms, which is nothing but 40. This is your L of u. So L of u, now I want to post 1 by 1 plus 2a. A value is 40. Therefore, your L of u is nothing but 1 by 1 plus 2 into 40, which is nothing but 240, 80, 1 by 81. So you got your answer. 1 by 81 into your bandwidth. How much it is? Your bandwidth is 4 Mbps. This is your throughput, my dear friends. Your throughput is 4 by 81, 10 power 6 bits per second. 4 by 81 into 10 power 6 bits per second. And this question is very important. It is given by IISc Bangalore 2003. This question. He is also asking throughput in sliding window protocol. This time it's not stop and wait, sliding window protocol throughput. Sliding window protocol throughput is asking. Same. Your throughput is nothing but same like that only. L of u into bandwidth. But in this question, bandwidth is not mentioned. You observe what are the parameters are given. Window size 5 packets. First parameter. And each packet size is 1000 bytes long. And the transmission time for such packet is 50 microseconds. And the propagation delay over the link is 200 microseconds for every frame. For one frame, you are going to get the acknowledgement at 200 microseconds. So let us take those precautions. Window size is 5. So I cannot implement this equation because the bandwidth is not mentioned. Otherwise, you calculate the bandwidth using TT is equal to L by B, no doubt. And your packet size is equal to 1000 bytes. And your TP is given 200 microseconds, and TT also given 5 microseconds per packet. For one packet 5 microseconds. So using this TT into L, you can able to find bandwidth, so that I can able to find using this equation, no doubt. But you can also find the throughput in different style. What is that? This is a second throughput formula. Your message size divided by your total time. This is also one style of equation to find the throughput whenever in the absence of bandwidth. Now, what is your message size and what is your total time? So let me give you, message size is nothing but 1000 bytes. Each frame is 1000 bytes. How many frames like that? 5 frames, because your window size is a 5. What is the meaning of 5? 5 frames or 5 packets at a time into 5. This is your total message size divided by your total time is nothing but TT plus 2 into TP. What is your TT? Don't calculate TT for entire message. You calculate TT only for the first frame only, because in sliding window protocol, your next frame transmission times are overlapped with your first frame propagation time. Again, I am telling you, your next frame transmission times are overlapped with your first frame propagation time. So you want to have proof, I can give you. So according to that, my first frame TT, according to the given question, how much? 5 microseconds per packet, and that packet takes 200 microseconds one side and 200 microseconds other side to get the acknowledgement. Therefore, I am sending using 5 microseconds. This packet get acknowledged. Please understand. This packet gets acknowledged after 200 microseconds of TP and 200 microseconds of this. Now, what is your total time? Don't write your total time that frame 1 5 ms and frame 2 next 5 ms and next 5 ms and next 5 ms. It's wrong. Why? Because sliding window is maintaining a concept of a pipelining. What is the meaning of pipelining? In the waiting time of the sender, this is completely waiting time only. In the waiting time of the sender keep on transmitting the data. That means next 4 packets of your transmission time is overlapped in this particular time. So I am sending a frame 1 and I am sending a frame 2 and I am sending a frame 3 and I am sending a frame 4. That's it. You got transmitted all the 5 frames which are in this only. Please understand, they are overlapped because your next 4 into 5 microsecond, 20 microseconds are overlapped in this 400 microseconds. So I will not consider their transmission times as your total time. That means within a 405 microseconds time, I have transmitted what? 5 of your frames. This is why the sender do not have any kind of what? Waiting time. So what is your answer? Your answer is TT is 5 microseconds. And your 2 into TP is 2 into 200. So you got your answer 5000 bytes by 405 microseconds. So well, my dear friends, so it's not a 5 microseconds, it's a 50 microseconds. So what is the idea? First frame transmission is a 50 and next frames are transmitted in the duration of your 2 into TP time. Therefore, your value is TT of first transmission. Your value is TT of your first transmission and double of your TP. You are successfully transmitted TT of first transmission plus 2 into TP. This is my total time. So during this time, the sender might have pushed remaining 5 frames because 5 into 50 is at 250 microseconds. That is overlapped in your 2 into 200 microseconds. So your answer is how much? 50 microseconds plus it is a 400 microseconds. Total time is 450. So 5000 bytes by 450. Your answer. So your throughput is 5000 bytes by 450 microseconds. This is equal to, your answer is in the form of what? Observe carefully. Everything is a bytes per second only. So I am also going to provide your answer in the form of bytes per second because data unit is in the form of what? Bytes only. So which is nothing but 5000 divided by 450, which is 11.11. Mu s is nothing but 10 power 6 if you bring it to numerator. So this is your answer. Finally your answer is. So my dear friends, so this is how you can able to solve some of the questions of sliding window protocol. This is your homework task. What is the efficiency of the sender? What is the link efficiency of the sender when you are sending a window size is equal to 127? There is a rule. What is that? If a window size greater than is equal to 1 plus 2a, then your efficiency is 100%. You need not calculate. So first check this. Your window size 127 is a greater than is equal to 1 plus 2a or not. A is nothing but TP by TT. If yes, it is 100%. If not, if this condition is a fail, then you go to the second condition. What is that? You know. Your efficiency is window size by 1 plus 2a. Already window size is given to you. You find your 1 plus 2a value, then you will understand if not 100%, what will be the link efficiency. Okay friends, so we'll meet in the tomorrow session, that is stop and wait ARQ protocols. That means I'm going to discuss in the tomorrow session error control protocols, ARQ, automatic repeat request, which is for error control. This is our tomorrow 10 p.m. to 11 p.m. class. I'm going to discuss tomorrow the first variety, which is based on stop and wait, which is nothing but stop and wait ARQ. Well friends, please like lecture and also give a positive comment, then I can able to prepare further lectures. Use my referral code to get the maximized discount into Unacademy, and as well as once you use my referral code to get the admission into Unacademy, I will be your guide so that I can able to give you each and every day. So thank you very much for sparing your valuable time. We will meet in the tomorrow 10 p.m. to 11 p.m. class and a special class 2 p.m. to 3 p.m. Thank you very much.